You may have come across something in your feed that says a revolutionary new air conditioner. And initially when I clicked on this, I was unfamiliar with the Tech Ingredients channel. However, it's definitely worth a watch if you're into kind of the science and technology side of things. But when I clicked on it, I expected to see another over unity power, free energy type of bogus claim. But what I actually got was a very detailed and intellectual explanation of different thermodynamic processes in making an air conditioner that doesn't use a conventional air conditioning thermocycle. So what I actually saw was this, or what I should say, I didn't see this. It's what I wanted though. So I painstakingly went through the video with my notebook and drew it out. I would ignore what he was saying. I would look at where his tubes were going. I would then go back and play it and see what he was saying and explaining it. And it all makes sense. However, it's a little hard to follow once you get past his initial explanation without a diagram, I found. So let's ignore all of this down here and see what was happening. And the explanation was really good. Essentially, if we have room temperature air with, say, low to medium humidity or even high humidity, if you're by the ocean, for instance, you run that in through this tube chamber with all the surface area with this water spraying down so that there's lots of surface area, lots of surface for that water to evaporate. What you get is the air being cooled and you get high humidity out. So cooled air but high humidity. And there's two mechanisms that's happening here. So one is that we're measuring relative humidity. So if you cool something, the amount of water in air that is cold versus hot air, the amount of water that it can hold are very different. So hot air can hold way more water in it than cold air. So as we cool it, that relative humidity is coming up. But we're also evaporating. So as we evaporate, even though it takes in a lot of energy, it's going with the airflow. So we're getting high humidity out of here. But for this whole system, we actually end up with fairly low humidity. And the way we do that is the rest of the system is essentially a dehumidifier. So it's kind of funny to look at that. The bulk of these 4 swamp coolers are a dehumidifier. And so it's a bit convoluted. Let's look at the most important thing for people is the airflow that you're going to receive, the stuff that you're being cooled with. So that means we can ignore all of these. We can ignore these 2 chambers in the bottom. We can ignore this whole kind of loop about the desiccant. So we have air going in that's room temperature, low to medium humidity, and it goes through that process. But that process is a little bit different because we're using a desiccant. And when we use a desiccant, what happens is we want to cool desiccant, and as it sprays down, it pulls in humidity. It's still evaporative, so it's still losing energy, or I should say that evaporation is still taking in energy, but that pulling in the water with this liquid desiccant is, I guess, exothermic in a way. So it's actually warming up there. So normally we're expecting out of this loop, we would get cool but humid air. But what we're actually getting is the reverse when we use a desiccant. We're getting dry but hot air. So that desiccant reaction is releasing a lot of heat, but taking away all that water. So, I mean, if we just put it directly into one of these right away, the net effect is we've got this warm, hot air. We cool it and add humidity. We're back to square one. We need to cool it in between and cool it to, say, room temperature. So, essentially, if we run it through a radiator that is already cooled, then we can take out all that heat. So imagine a radiator cooled infinitely, perfectly to room temperature. No matter what heat you put in, it's always room temperature. And if we do that, we should get room temperature, but now dry air, like no humidity air. And how he's accomplishing that is he's taking his radiator and he's running it through another swamp cooler. So the water is exiting through the pump. This water will be cooled, as he demonstrated with his column system, runs through the radiator. It's counterflow, so cold going this way, hot air going this way, so that there's the largest temperature differential between it. Or I should say, for the longest time. And then the radiator comes back and goes into swamp cooling mode. So it's spraying, evaporating, and cooling that water that just received all that heat. So we now have this loop taken care of. For this desiccant loop, we're going to actually need the desiccant in two states to do what we want. In this first state we already mentioned, and what we need is cooled desiccant so that as it runs through this swamp cooler effectively, that it can pull in that water, and then that results in its dilution. It's still cooled, but it's dilute. In order for it to release that water so that we can keep using it, we have to heat it. Because when we run it through this process now, it's hotter than the air that's going through it and can easily release that humidity. So when it's hot, it's not going to act to take out humidity as much. So by heating it up, I think he showed about 40 degrees, maybe 50 degrees Celsius, it allowed the air that was flowing in, that is medium to low humidity, to be cooled, but then become very humid because it's taking a lot of that water with it. So through this process, it leaves us with concentrated desiccant, but that desiccant is still warm because we had to heat it up. So we run it through another heat exchange process through a radiator, just with the desiccant in it to cool it for this process. And to cool the radiator, there's several different ways, but the way he used was another swamp cooler that recycled onto itself. So this water is cooled, goes up, it sprays it on these foam blocks, and then they evaporate, cooling. So these water supplies, as he mentioned, will drop. This needs to be a clean water supply. This, he mentioned, could be potentially gray water. You could refill it. And this water, since it's a closed loop, it could also potentially be gray water. So that's the whole system. We are essentially concentrating our desiccant with this. We cool the desiccant so that we can use it in a regular heat exchange, regular process to dry the air, which results in hot-warm air, cooled to room temperature, then cooled below room temperature while putting back humidity into it. So hopefully between his video and my quick whiteboard explanation, you now fully understand how this process works.